Have you ever wondered how you can measure how fast your code in Python? How we can profile it? We often happy that the code is done and we celebrate it when the script is working. But what about when it takes 5 minutes for your code to run? Or when your laptop fan starts spinning very fast whenever you run your program? That is when you just realize that writing a code is not the final destination. You need to take care of efficiency of your code. Today I will show you how you can measure, profile, and optimize your Python code using a few useful tools that are typically underrated. Let's jump right in. As an example, here's a simple task. It is summing up numbers from 1 to 10 millions. As you can see, it goes through the loop and it will add to the total per iteration. On the right side, however, you can see the faster code. Both do the same thing. But one takes seconds, the other one, you may ask, is only milliseconds. Let's see how we can actually measure these two simple programs. The easiest way to measure how long your program will run is using a tool called timeit. It's part of the standard library. You don't need to install any extra libraries into your Python project. You can easily use it. In this example, you can easily import the timeit. In the first line, you add the for loop into the timeit function, and it goes simply through all the loops. In the second line, we have compression time. In the function of timeit, in this output, we will use the list comprehension. Basically, we add i's to the list per loop that we have until the 10 million. You can easily add loop time and compression time to the print, and you can see the results in the output. Timeit runs the code multiple times and it gives you the average execution of the time that it took for that function to be run. When you compare the results, you can literally decide which one is faster. Most of the time, list comprehensions outperform loops because they're already written in C and they avoid any overhead in the Python. Okay, but what when your code is not just one line of loop? What if you have the big chunk of program and you want to test? That's when the profiling comes into the place. The built-in cProfile will show you which function of your program will take the most time. So in this example, we define the function slow function. And it's basically the slow function that we defined before. It goes through the loop and adds to the total. We add it as a cProfile run and the Python prints a breakdown. Which function ran, how many times, and how long it took. If you want deeper insights, you can use line profiler, which you can install it by a pip. It shows you exactly which line of your code is the bottleneck for the whole program. This is how you move from just guessing and just looking for something until you know exactly what happens. Now let's move into the data territory. For example, using Pandas. One of the most common mistakes that I see is people looping through the rows like this. In this example, we define the df, which is basically the data frame from Pandas, and the values are in the range of 1 million. To calculate the square, if you use per elements the square like this, it will be pretty slow. And the larger data frame that you will have, the slower it gets. Instead, you can use vectorized operations, or you can use apply like this. So for the vectorized operation, the first line shows you how we can do it. Basically, you tell Panda that per value you want to make the square and you want to allocate it to the squared. Or in the second line, you use apply. And as you can see in the apply function, you can use lambda. And the benefit of lambda is that if you want to have different operation per element, you can definitely do it without compromising the speed of the operation. Pandas built on top of the NumPy, which means that those vectorized operations are happening in C. The fewer explicit Python loop that you write, the faster your code will run. Because at the end, if you keep your code running in the C instead of running in the Python, you will get much more faster results. Speaking of NumPy, let's see why it's so fast. In this example, we import NumPy and we define numbers of the list in the range of 1 million. We use timeit to calculate how long it takes per element to be squared. At the same time, we define an array, which is the NumPy array in the range of 1 million. And we do the same operation for this one. And as you can see in the output, you can compare NumPy with the native Python program. NumPy arrays are vectorized, optimized, and they are written in C. It means that all the heavy lifting operations are happening outside the Python. That's why you can perform millions of operations just in short amount of time. If you are working with numbers, NumPy always beats the list every time. Alright, let's put all the things together. Here's a small challenge. We want to calculate the average length of word in the whole database that, for example, we have. Let's define it like this. We define the sentences array like that. Python is fast, optimization is cool, loops are slow. We define the empty list of length, and we go through the loop of sentences. Per element, we split the sentence. For each sentence, we split it into the words, and per word, we calculate the length and we add it to the total. And at the end, we append the average into the length. What would you do if you want to optimize it? You can pause the video and think about it yourself based on the lessons that you learned today. Let's start with the solution. You can basically write everything in just one line. Let's see how the answer will look like. So in the comprehension list, we loop through the sentences instead of using the loop from the Python. And per each sentence, we split it to the words. And for the words, we calculate the length and we sum it to have it as a total. We divide it by the number of words that the sentence it has, and you have your average. It's the same logic. It's only one line compared to the 7 lines. And it runs up to 5 times faster for the large datasets. You can even vectorize this further if your dataset is already in Pandas. So what we learned today is that working code is good, but faster code, you may ask. This is the professional code. If you find this video useful and you are really interested into the optimizing the code, especially to understand how memory works, I would recommend you to click on this video here. Until the next video, good morning, good afternoon, good evening.